Hello, everyone, and welcome to today's SANS webcast. BloxOne Threat Defense, Strengthening and Optimizing Your Security Posture from the Foundation Up, sponsored by Infoblox. My name is Carol Auth of SANS, and I will be moderating today's webcast. Today's featured speakers are Srikrupa Srivastsan, Director of Product Marketing at Infoblox, and Dave Shackelford, SANS Analyst, Instructor, and Course Author. If during the webcast you have any questions for our presenters, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Dave.
Awesome. Thanks, Carol. And hey, thanks everybody for joining us today. This is a fun conversation to have. And of course, as I'm sure many of you have probably thought about just looking at the title of this webcast, the fine folks at Infoblox are going to be talking about their BloxOne Threat Defense. But before that, I want to talk about some of the underlying pieces and parts of sort of what's going on in your environment and sort of lead into that a little bit with the view from a security analyst or security operations type of person. So let's go to the next slide, since these title slides aren't very much fun and we don't want to hang out there too long. And here's today's speakers. It's me, hey, and I'm going to be joined by Krupa from Infoblox here momentarily. And so let's get off this slide as well. There we go. So let's talk a little bit about sort of what's going on out there. And not only as a SANS instructor, but also as a consultant that's out running around in the field just like everybody else is. I think this is probably the captain obvious statement of the day, right? Threats are more advanced than ever before. We know that. Unfortunately, these guys aren't waiting for us to catch up. And between all the various forms of attacks that are coming through, between phishing and other social engineering types of attacks, some of the really advanced malware that's consistently changing and morphing on us, these low and slow attack styles. I mean, we've got lots of trouble. And, talking to security analysts and professionals in the classroom or as consulting clients that I work with, I think people are really frustrated and they're really trying to go back to the well and say, could we do better? Could we actually, sort of improve the state of what we have in place today and sort of level ourselves up and get more from some of the technology that we've got in place? I think the answer is yes. And I'm going to make that case here in just a little bit, and I know Krupa will as well. But the thing is, we do have a lot of detail in our environment, and it's really more a matter of how to get it and how to make use of it and leverage it most effectively. And there's some really interesting things evolving out in the landscape of security technology I personally think can really help us. So let's go to the next slide. And, kind of going back to what I was saying just a minute ago with things that are happening in the world of security operations, I spend a lot of times with SOC teams and things related to SOC teams, not necessarily just those in the SOC proper, watching the big dashboards and kind of tracking things, but also those connected groups and other related roles within the organization, like forensics and other types of investigation teams, et cetera. We're seeing some things that are sort of increasingly causing consternation. Number one, more custom malware. That's been a significant and fairly dramatic rise in the last couple of years. And obviously, if you've been relying on signatures that are no longer catching things, that's no good for us. People using built-in commands, the attackers using built-in commands like PowerShell. I mean, PowerShell is sort of the easy example here, but they're using all sorts of quote unquote living off the land style commands that don't get flagged. These are things that are built into Windows operating systems or Unix operating systems, and they're using them to great effect. We're seeing longer attack periods where these guys are hanging out. They're not making as much noise as they used to. And really, what's the whole point of this? We're not going to stop all the attacks. I think we have to be, sort of prudent and exercise common sense. These guys are going to get in sometimes in various ways. The key thing for us, I think, now is to try to reduce and focus on reducing dwell time. If these guys get in, let's find them faster and get rid of them more rapidly and effectively. And also look for specific indicators in the environment that can help with that. And that really comes back to that principle I was sort of getting into a moment ago, What kinds of indicators are there? What kinds of pieces of data or details about how our environment is functioning could benefit us and start telling that story a little bit better? One of the big trends that we've seen significantly sort of taking shape over the past decade, or maybe even 15 years, if you want to go back that far, is just this mountain of data. It's just an overwhelming amount of data that is sort of drowning us now. And you know, again, I always laugh when I talk about this massive data influx that we've got in security operations, because we didn't used to have that and we used to beg for it. Well, now we got it. And we've still got to try to wade through and find the things that are most valuable. So just because you have more data doesn't mean that it's useful data. It doesn't mean that it's useful in sort of going back, finding things more quickly, and then, of course, responding appropriately. So let's go to the next slide. So going back to, you know, this whole idea of sort of processing the data, you know, again, it's a real challenge for us. And the other things that are happening in the world of security operations, you know, it's tough because you hear all these statistics out there where, you know, we've just got this incredible shortfall of security staff and security personnel. Even those that don't necessarily have the, you know, shortfall per se, people aren't just getting budget to go hire anybody they want to. So you're having to make do with the people you have, and, you know, to some degree, in many cases, the skill sets that you've got too. And you've got more events to respond to. You've got more incidents cropping up all the time. And, you know, I hear these consistent complaints. I think people get very burnt out in the security industry. And, you know, I know that they do, just because people are struggling to, you know, do 1 or 2 or 3 jobs without necessarily getting any help coming in. And what that means is we've got to be more efficient. And I think if there's maybe any emphasis out there in the world of security ops and security operations centers, it's asking ourselves, hey, how are we going to do that effectively? How are we actually going to sort of look across the landscape of our technology stack? And there's more technology than ever before, and I don't need to regale you guys with that. I think we all know that, you know, between internal infrastructure, cloud environments, lots of custom applications, you know, lots of encrypted traffic, like the list goes on. We've just got so much stuff on our plates right now that it really feels like people are drowning in this. And again, going back to the original point, we're looking for ways to sort of ask better questions of the environment and hopefully improve the efficiency of how we do security operations altogether. Let's go to the next slide. So these are some of the things that I see consistently out there. If I wanted to break out those big issues, and I teach lots of classes on security operations, and I consistently get lots of questions coming from my students and really from the SANS community altogether. One of those questions is really, what are the most critical skills? If I had to really drill down, what are the things that I really need to focus on to improve security operations within the organization? And by the way, this goes for, I would say, any sized organization, certainly medium-sized orgs and above. Even small organizations can still benefit from some of this. But I'd say event management and monitoring, in other words, seeing more event data and ideally useful and interesting event data, that's one of the biggest things we've got to get better at, just getting that data in the first place and then being able to start really drilling in and finding things. We need to be able to take that data, and the way I always describe this is tell stories, right? So be able to tell better stories out of the data, which means, do I have 3 or 4 pieces of information from my infrastructure? And I think a lot of times when people get into the realm of information security and they hear event management, they think, oh, it's security event, right? So it's going to be things coming from, you know, endpoint security, or coming from, you know, network intrusion detection, or maybe from firewalls. The answer, of course, yes, you do want all that. But I think there's actually a lot of sort of auxiliary and additional detail in the environments that we all operate in that can help tell those stories more effectively. And here's the cool thing, just about everybody has some of this. And so we'll get to that here in just a minute, but I think it's useful to take a step back and realize we have infrastructure details, we have just IT technology stack details that we can go and pull and start making use of, potentially in addition to some other things. Of course, that's going to lead to investigations, which today, as again, we'll talk about here in a moment, and Kruba has more to say on this than I do. I think we're looking to find places where we're just getting our time sort of chewed up. And I can speak from experience here because I remember distinctly starting off in the world of security in the 90s. And yes, I'm old, but going back to the 90s, even into the early 2000s, we were really doing things incredibly inefficiently. I could probably rattle off 10 to 15 different operational areas in security where we spent a lot of our time having to go through manual types of activities that really just didn't benefit us, and we're looking to try to remove some of those today. So too many manual tasks and a lack of optimization across our tool stacks too. So there's again a whole realm of things going on in the world of security operations that it's all sort of converging at the same time. We need specific skills, we need more data, we also need the ability to do more automation around some of the details and data that we've got to be able to do investigations better. So let's go to the next slide. And this is really what I call moving to more proactive monitoring. In other words, getting ahead of this stuff as much so as possible versus just waiting for that wash of data to come over us and say, here's all this information. What are we going to do? Let's go find some things. Let's go do some things like threat hunting, which I'm a huge fan of, because if you've got all the details and the data and you've got some semblance of an idea as to what might be interesting or suspicious, go find it. Go look in the environment, and that's helpful for us and sort of puts us a little bit further ahead of the problem. We need to be able to go find attributes of the environment as fast as we possibly can. In other words, we don't want to have to go dig around in the weeds for key details that are commonly seen as indicators in attack scenarios. And we know a lot of those today. And, again, the good news for us is that we have a lot of core infrastructure services that provide more insight than people realize, and we can usually get that detail and get that data pretty effectively. So let's go to the next slide and really start getting into a couple details about this, because I think if you really start looking, and I've heard this, and I've gone sort of back and forth over the last, call it 10 to 15 years again, because we've learned a lot. I hear some of these presentations out there that people give, and you guys have probably all gone through a few of these, where it's like, oh, the attackers are winning, blah, blah, blah. Well, they are winning because they're not constrained by the things that we are, but that doesn't mean that we're just wallowing. We are learning, and consistently in pretty much every single breach and attack that I've been associated with investigations around, what we found is that these guys do leave a trail. There's no attacker out there that is capable of completely eradicating every single detail. Some of them are, vastly better than others at minimizing that and concealing their footprint as much so as they can. These really sophisticated folks know what they're doing there, but there's still things out there that are useful and practical for us to be able to pull from. And some of that might be at the system level. So getting down to some of the different types of system artifacts that these guys leave behind. So whether that's traces of files or whether that's just log entries or other things, behavioral traces. The classic one these days that, everybody sort of knows now is workstations trying to talk to other workstations during lateral movement scenarios. Well, that's a pretty good behavioral indicator if you can see it. We're not very good at monitoring east-west traffic. That's a different discussion. But nonetheless, if I see one endpoint trying to talk to another in any way, that's weird. So yeah, behavioral traces. Things like network forensics. So, think about the kinds of things where you've got lots of different devices. You got proxies, for example, that people are having to go through on their way out to get to, different types of sites. Well, how often do you really see 100% net new domains that people are going to, or maybe unusual domains? You should flag those. Those should be things really of interest, or sustained types of sessions that stay in place for far too long, perhaps at unusual times of day. I mean, who knows? The list is very long there of network forensic details or data that might be practically useful for us in ferreting out some of these attack scenarios happening. But we have a huge number of online indicators and patterns, and we really just need to find tools and develop some workflows to go and dig into this stuff. So let's go to the next slide. So I want to talk a little bit about some DNS-related indicators. And I'm a huge fan of basically latching on to DNS like your life depends on it in the information security field, because DNS can tell you so many stories. There's just an enormous number of things that we can glean out of DNS-related indicators, and all of us have DNS. There's not a single organization out there today that doesn't have significant DNS presence of some type. Think about all the different ways you can figure out what's happening solely by looking at DNS. Internal DNS lookups. So this is your end users, which are number one point of compromise today. If an attacker gets onto their system and pivots out, they may very well be doing some sort of internal lookups initially that can tell you something is unusual. Hey, that's not really normal for Dave to be out there doing something like that. Proxies and gateway devices, as I just mentioned a minute ago. Domain traffic patterns, and just being able to monitor and develop those over time. Looking for known good or bad domains, which might be a factor for threat intel. If you know there's a bad domain and it's got a reputation rating associated with it, well, that's an obvious one if it pops up on your radar. Looking for DNS registrations. So if you see a DNS entry, you see a domain that was registered 3 minutes ago, probably no good. So you can go down this sort of list of interesting factors, and I'm really not even beginning to delve into them, at the level that you would want to if you were doing this as a professional analyst. These are just some interesting examples of ways to think, and you all have DNS. Everybody's got it. What can you do with it above and beyond just doing name resolution? Let's go to the next slide. So I think, you can start telling some really interesting stories. You can start actually getting down to using DNS for better defense with some strong use cases. I've got a couple here that I find interesting, and I'm sure Krupa has lots more that she can share here because this is what she does, is deal with things like this. But if you look at domain reputation, we are doing a way better job as an industry altogether just thinking about domains and noticing when bad things are happening associated with them. And an easy example of that is things like phishing. So you see a lot of phishing happening today. It's got to originate from somewhere. Now, sometimes that might be a hijacked domain, or it might be something where it's totally a legit domain that's just doing abnormal things that are, unusual or bad. But sometimes it's domains that are just registered for phishing. So it's, the classic stuff where a certain letter gets replaced with a number, things to try to just trick people into seeing the domain and thinking it's okay when in fact it's not. But regardless of whether it's a good or bad domain altogether, monitoring altogether over time is what we want to look at. And so, doing things like reputation scoring, monitoring and, potentially alerting on actions where people are going out to domains or are seen interacting with domains that are known to be suspicious or definitively malicious, that is such an easy win for security operations teams. Let's go to the next slide. So indicators of compromise, like I said, these are some things that sort of piggyback on what I was mentioning a moment ago. You can develop your own indicators. And so this is one of the things I talk to a lot of teams when they're, starting to delve down into threat intel. A lot of people ask me, well, what's the best threat intel? Do I go buy a feed from a vendor? Do I go buy multiple feeds from vendors? Should I try to tap into things like the ISACs or sharing groups that might be part of your industry or verticals? Sure, all those things are great, but you also have a lot of your own data and details to build your own threat intel set. And I think that's where you should start, honestly. I think a lot of times if you go in your own house first and start looking at, things like your local DNS for internal assets and systems, and then you start looking to see where your DNS is going and doing outbound queries to resolve those other types of names and domains. Looking at DNS entry TTLs, like I said, if you see really short TTLs, that is a classic hallmark of things like botnet behavior. Looking for those patterns of DNS lookups. You have all that detail. If you're seeing consistently that there's a pattern of one system going to numerous net new domains, over time, that's probably something suspicious that you might want to go track down and look into. You can obviously get things like logs in the local, devices or network devices that could help with DNS resolution, even things like browser types of logs, absolutely can start helping you to build a better set of data for threat intelligence. And then you can tie in things like professional feeds or feeds from industry. So let's go to the next slide. So, tying that thing into, things like threat intel, like I said, one of the things I've actually seen consistently happening in a lot of the sort of sharing groups and teams that are out there, irrespective of industry, whether, energy sector, financial, healthcare, you name it. People are actually taking some of the details from their DNS and from some of their internal sorts of resolution or, so forth, and sharing it. So potentially anonymizing anything that could be compromising for your own internal users. You're not going to share your internal domain space, for example. But if you start seeing a repeated pattern of unusual queries or responses coming from an external domain, hey, why not share that and say, hey, if you guys are seeing this, it's probably something unusual. We started to see some unusual activity or behavior or potentially tied to a definitive incident or attack. You can share that kind of stuff. So again, threat intel is a big part of this. So let's go to the next slide. So just to tie in here, and I won't spend too much time on it just because, again, this is sort of a topic in its own right, but I think there's a lot to be said about integration of these data sets and the sorts of use cases we've been delving into for automation, because none of these types of tools and platforms and security events and details are going to be explicitly used in a vacuum. And the more of those you can tie together and start telling stories, and ideally doing that in an automated way, the better off we're going to be. And that's really led to this whole market in its own right called SOAR, Security Orchestration and Automation, where we're trying to tie together some of this. So vulnerability scanning details, or some context around the assets that we do see communicating, validating some false positives, prioritizing things a little bit more effectively, and maybe automatically opening a ticket, or potentially, say, blocking a domain automatically while we do a lookup and investigate it if it's something that has been seen on a reputation blacklist. Like, even though that sounds like a very trivial or simple use case, and it is, it's also something that could very easily be automated and save you a ton of time versus having to, spin up one of your analysts for an hour or more to go handle that independently or uniquely. Let's go to the next slide. And to move to this, again, if you look at the benefits, as I said at the very beginning, trying to get away from manual tasks. We're trying to reduce human error, which does happen, especially when you're under fire. I can vouch for this myself. And we're looking to try to get things that work together as much as possible without sort of overcomplicating our environment. So, trying to figure out where the right level of automation is takes some time. There's some pretty well-described use cases out there for doing things like automated ticketing or alerting, or, as I said, in some cases, maybe some very basic blocking and tackling. But, again, you don't want to over-automate either, because that can be just as disastrous. So, take it slow, start building those really simple use cases that are potentially less intrusive. Let's go to the next slide. And this is just my, sort of final last point, if you will, on doing some automation around security operations specifically. And it's sort of a checklist, and you guys all have the ability to get these slides later on, but just based on my experience, these are some of the types of things that I recommend looking at first. So logs and events, system config data, things like DNS lookups, as we've been talking about, beginning to think through vulnerability scans and vulnerability details coming from those scans, doing things like opening tickets, as I mentioned, maybe blocking certain types of attacks, doing some email validation. The list goes on and on. I won't read this whole list to you guys, but what I found is that if you sort of put your heads together as a sort of security operations team and think about some of this, you're going to immediately find some places where you're spending way more time than you should. And the use of security orchestration and automation tools in alignment with a lot of these details we've been discussing from infrastructure can really go a long way to helping us get further, even when we don't necessarily have all the manpower that we would like to have. So let's go to the next slide. And I'll just sort of wrap up my section of this as I'm handing it off to Krupa, but I'm a big fan of DNS, have been for years. DNS, of course, is not the only core infrastructure type of service and detail that we can leverage. And Krupa has lots more examples, I'm sure, to give. But I do like DNS as a great starting point because you can start seeing some immediate benefits. Things like lookups and registrations. Obviously, DNS has been used consistently as an exfiltration or command and control channel too, which means it's not real DNS, obviously. It's DNS that is being used as sort of a smokescreen. But you should always pay attention to what's going on with DNS. And there's a lot of really great stuff that can come from that. So, Krupa, I'm going to hand it off to you.
Thank you, Dave. You did such a great job. I think I can just wrap up as well on DNS. Thank you so much for that setup. And I think the some of the things that Dave talked about, leveraging DNS as that first line of defense, and this is infrastructure that everybody already has, right? It's not an additional piece of network infrastructure you need to put in your networks. It's not it's not like putting something on a span port. This is critical inline infrastructure that all companies use and leverage. And it makes so much more sense to just look for malicious activity and anomalous behavior, leveraging this infrastructure you already have. And we like to call this as foundational security, right? So like I said, this is not putting something on top of what you already have. It's not adding to the security stack, which we can all agree is it's just growing. There are too many tools to manage. So the more effective way to doing security is to leverage this foundational infrastructure. And before I go into all the different ways that DNS can help secure a network, I'd like to take a step back and talk about how the threat landscape has evolved, right? As Dave mentioned, 15 years ago, 20 years ago, it was all about simplistic malware like worms, and antivirus was developed back then to address those type of threats. And then we saw a little bit more sophisticated rootkits and spyware. We needed something at the perimeter, like an IDS, IPS, or an next-gen firewall. And that was instrumental in blocking a lot of the spyware and rootkits coming into the network. And then threats evolved further, right? We saw the advent of advanced persistent threats. Now, these could not be mitigated with standard perimeter firewalls or perimeter devices alone, so we needed something more. And the sandboxing was born, right? So sandboxing technology kind of exploded these APTs in a controlled environment to figure out how it works. And then to figure out what's the malicious intent of those APTs, and then we were able to block those threats as well. And now, if you think about where we're today, the threats are getting more sophisticated, yes, but it's not just the threats, but the attack surface has increased as well. It's no longer about applications sitting in a data center somewhere. It's no longer about employees always coming into headquarters and working from, within the firewalls. It's about applications in the cloud. It's about using public cloud. It's about, employees working from wherever, right? From their home, from Starbucks, from remote offices, branch offices. It's also about SD-WAN type of branches that are directly connecting to the internet without happening back to the data center. So when you see all these new age kind of architectures and scenarios that are in use today, the attack surface greatly is increased as a result of that, right? And so it's kind of a double whammy when you think about it. More advanced threats, but also the enterprise is becoming more global. Its enterprise is becoming borderless, right? There are IoT devices connecting to the network, connected cars. Let's say you're a car manufacturing company. You want to be able to secure not just your traditional infrastructure and networks on which your systems are running, but your extended network, which is your connected cars. They need to be secure as well. Let's say you are a financial services company with a ton of branch offices. How do you secure those branch offices from threats that are coming from the internet? Things like that. And one of the common layers, underlying layers that ties all of these new things and new architectures is DNS, right? So anything that's connected requires a DNS for connectivity, right? And DNS offers this 360-degree view of all the activity that's happening on your network, or what IoT devices are connecting to your network. Now, they could be connecting to an IoT gateway, or they could be directly IP enabled, which means they directly interact with the DNS server. Your branch office devices, your servers in the branch offices, your data center, your hybrid cloud applications, virtual machines, your containers. There's like no end to connectivity, and all of those things leverage DNS and IP addresses. So when you leverage something that is so ubiquitous for securing your networks, it becomes a lot more cost effective and it becomes a lot more scalable as well. And some of the new paradigms that we're seeing today, we talked about migration to the cloud. Big driver of that is Office 365. I'm sure some, if not most of you, are deploying Office 365. I know we have here Infoblox. And all of these SaaS applications mean that you are not hairpinning traffic back to a server in a data center. You're directly going to the cloud to access your business applications. And this means that the perimeter no longer exists. And so how do you secure your Office 365 connectivity? How do you secure your direct-to-internet access branches like SD-WAN, right? So SD-WAN, I think there was a research report I read recently that said that 40% of branch offices are going to be SD-WAN branches by end of this year. And the biggest challenge there is you can't replicate your full security stack in these remote offices simply because it's cost prohibitive, right? But these branches are directly breaking out to the internet to access the nearest access point for the cloud applications and to get geographically logical language, right? And when you do that, when you're directly breaking out to the internet, your branch offices are exposed to malware attacks and data breaches simply because, like I said before, you cannot replicate a full security stack. You have to rely on some basic security functionality that's available with SD-WAN solutions, but that may not be enough, right? So again, these SD-WAN branch offices rely on DNS for connectivity. So when you leverage a DNS-based security solution, you can provide that same level of security that you can provide for your data center and headquarters to these SD-WAN branches. And we talked a lot about IoT. I'm not going to belabor that point. But again, the underlying infrastructure that provides kind of continuous visibility and that can secure your cloud applications, your SD-WAN, your IoT rollout, in addition to your traditional networks, is that DNS, DHCP, and IPAM. And just to talk about a little bit in terms of traditional architecture, maybe 5-10 years ago, right? Most of the architecture was about physical networking. You had physical appliances, you had a physical, like a data center, and all the applications resided in that data center, and your branch offices were connecting via MPLS or WAN to those data centers, and they were routing traffic back to those data centers. And when you think about DNS, DHCP, and IP address management, a lot of the stuff was done manually using static configurations, Excel sheets to manage DDI protocol serving situations. And there was pretty much zero to very little automation, right? And the security was all about perimeter-based security. But when you look today at where the architecture has evolved, we talked about cloud, SD-WAN, and SaaS. Now your branch offices are directly going to the cloud. They're connecting to AWS, Salesforce, Office 365, or Azure, Google Cloud, and the list goes on, right? And you don't see those traditional MPLS or WAN-based connectivity that goes back to your headquarters or data center. These branch offices are directly going to the cloud, as are the increased use of cloud applications from headquarters and your users, wherever they may connect. And when you think about core foundational elements for any architecture, traditional architectures or new architectures, it's DNS, DHCP, and IPAM, right? So for those of you who are not familiar, DNS provides that phone book-based lookup for your IP addresses. Let's say you're trying to connect to yahoo.com servers. DNS knows the IP addresses of the yahoo.com web servers so that you don't have to memorize it, and it connects you to those servers. And when you look at DHCP manages the automatic allocation of IP addresses to all types of devices, right, dynamically. And a robust integrated IP address management solution will give you the entire IP address space, and not just IP address allocation, but also it forms that authoritative database of all your connected devices that receive an IP address. It could be your smartphones, it could be your tablets, it could be your servers, it could be IoT devices, it doesn't matter. Your IP address management solution provides that ubiquitous visibility and single source of truth. Now, when you leverage that for security, this is what that looks like, right? So your DHCP server can fingerprint every type of device that is connecting to the network. It knows, it has fingerprint information about what type of device is connecting. So is it a MAC address? Is it a PC? Is it a Mac? Is it a PC? Is it a smartphone? Is it a tablet? So all of that information now gives you more additional metadata or context about not just an IP address of an infected or compromised device, but you now know what type of device it is. And then when you look at network location, so your IPAM metadata provides exact, precise location of that compromised device. It'll tell you if it's a device that is in the data center, maybe it's a financial server running critical applications, maybe it is a branch office device, maybe it is somebody's laptop who's connecting from home that's compromised. So you're getting more forensic information about that compromised device than just an IP address. And that is possible only when you have an enterprise-grade DDI solution that can provide you that information. The other thing it provides is also user details. So by connecting with Microsoft AD, you also know who that device is assigned to. So you get that information as well. And when you look at DNS historical information, you get information about where that device has been connecting to. I know Dave talked about internal DNS lookups. So you know exactly which internal resources that device has been accessing. Dave also talked about going to the internet and going to different locations at a fast rate on the internet. So you get all that information about that the device, so you know whether it's behaving suspiciously by looking at the historical DNS lookup information. Now, let's think about adding threat intelligence on top of your DNS server. So you have all this contextual information, which is great. How about blocking these malicious activities at the DNS layer? And when you marry your DNS server with threat intelligence, you can do exactly that. You can not only detect this activity, but you can block that malicious DNS requests that are going out to bad sites or CNC servers on the internet, or let's say it's going to new domains on the internet, newly observed domains on the internet. You can block the DNS request. And you can do that by leveraging threat intelligence and what's called an RPZ feed, an RPZ-based blocking that's available in your DNS servers, right? So now you are detecting and blocking malware callbacks. You are blocking ransomware from downloading additional malicious software. You can block phishing type of or exploits, whatever. Most malware leverages DNS lookups at some point, so you can now block it at that level. And now you get, and the advantage of blocking at the DNS is that you are blocking it much earlier in the cycle than a next-gen firewall would block it. So now you're actually reducing the load on your next-gen firewalls because you're blocking a lot of the bad stuff at the DDI layer, and you're giving back some processing power to your next-gen firewalls, which is a more cost-effective way to do security when you think about it, right? So we talked about CNC blocking, we talked about ransomware, and data exfiltration as well. So when you think about data exfiltration, a lot of the times compromised devices will leverage DNS queries to append data to it and send it out to a CNC server. So when you block that at the DNS level, you're not actually closing a critical gap. And you can do that using threat intelligence, You can also do that using analytics, looking at DNS queries that are going on in real time, and blocking that using analytics, right? And like I said before, DNS can provide that same level of security for your data centers, for your headquarters, for your multi-cloud environments. Let's say you're using a combination of AWS, Google, Azure. It doesn't matter. You can leverage. You can use the same level of DNS security to block malware, data exfiltration, DGAs, fast flux, no matter what your architecture looks like, right? Your IoT, even containers, you get full visibility into all of the activity that's going on and all of the connectivity that's going on, even in containers and your branch offices, right? And the advantage of leveraging um, an integrated DDI solution for security is that you can see everything that's going on in all of these parts of the network in a unified console, in one report, right? One set of reports. So you know exactly where the compromise is, what type of compromise it is. Is it a ransomware attack? Is it an exploit kit? Is it phishing? Is it data exfiltration, DNS tunneling? All of that information you can get in one console. And you not only stop how do I say this? You can not only block all this malicious activity at the DNS level, but you can also trigger downstream remediation actions. So when you look at all the ecosystem integrations that you can use with a DNS solution like Infoblox, is that you can trigger a scan from a vulnerability scanner. Let's say a device was doing malicious requests to a known CNC site and you blocked it at the DNS level. You can also trigger a vulnerability scan from a Rapid7 or a Qualys or a Tenable, and not wait for the next scan window to scan that device. So now you're doing real-time automatic remediation. You can also send this information to your SIM solution, like a Splunk, right, or McAfee. And now your SOC teams have more contextual data. So you can send information like, okay, it is this device in this part of the network assigned to this user who's also been doing X, Y, and Z. So now you're sending a lot of contextual information using our BloxOne solution to a SIM. So now the SOC analyst can correlate better. You can send it to a NAC solution like a Cisco ICE or a Forescout. And now that can knock the device off the network and not allow it back on the network until it's been cleaned up. So there are a lot of these use cases that can be enabled with a fully integrated DDI security solution like BloxOne Threat Defense, right? And there is like no end to the amount of integrations you can do. And this goes back to the point that Dave made, which is, SOC teams and security operations teams are struggling, right? They get too many alerts, too many tools they're managing, very little automation. So when you automate some of these remediation actions with BloxOne and with the ecosystem integrations, you're now making their life a lot easier. And with all the contextual data that you can provide to a SOC team, they can now prioritize which alerts are important. And they know which alerts all belong to the same threat. A lot of the times we see security operations teams chasing after alerts, which all are part of the same threat campaign, the same malware campaign, but they don't know that because they don't have that context. But when you leverage DDI data, they can get that context and decide that, okay, these are all the alerts that are part of the same campaign. I've taken care of it, so I don't have to worry about that. I'm going to go to the next set of alerts, right? So there's a lot of the prioritization that SOC teams can do by leveraging the DDI data. And that's something that's very unique just because of where a DNS server sits in the network. I talked about SD-WAN security a little bit earlier, but just to bring the point home, it is really cost prohibitive to put in a full security stack in an SD-WAN branch, which leaves them exposed to malware attacks and data breaches. So when you leverage a cloud-based DNS security solution, it's a lot more cost-effective way to secure those branch offices, because all your internet breakouts, let's say the branch office users are going to Office 365 or cloud-based applications, You can route that request through a cloud-based DNS security solution like BloxOne, and we can detect malware, we can detect data exfiltration, detect any malware campaigns. So you can leverage DNS as that first line of defense, and then you can go. That traffic can be routed to Office 365 or whatever cloud solution that the branch user is trying to access. So now you don't have to put in a lot of equipment in those SD-WAN branches. It's lightweight, it's cost effective, and also it's a scalable form of defense when you look at DNS, because theoretically DNS security can scale to the size of the internet. There is every connectivity, the internet relies on DNS, so when you put security there, you are like covering the majority of the threats and majority of the infrastructure out there. In terms of the actual protection that you can get from a DNS security solution like BloxOne is, like I mentioned, you can combine behavioral models and threat intelligence with highly accurate indicators of compromise to get 360-degree protection, right? What I mean by that is the behavioral models and the analytics can detect zero-day threats where the destination that the connectivity is going to is not necessarily classified as a bad destination, so it doesn't have any reputation associated with it, so you don't know whether you should block it or not. When you look at the patterns of queries that are going on to those destinations, you can check for things like data exfiltration, domain generation algorithms or DGAs, fast flux type of threats, fileless malware. So all of those threats can be detected only by leveraging analytics and behavioral models. So you can do that on the DNS layer and block those threats. Of course, we talked a lot about threat intel, and some of the things that Dave talked about from a threat intel perspective are spot on when it comes to stuff that you can detect and block on DNS, newly generated domains, CNC servers, domains associated with ransomware, phishing, you name it, right? And then you can also do signature-based detection for protocol-type attacks like DNS-based DDoS attacks like amplification, reflection, floods, and things like that. We didn't really cover a lot of that here, but the bottom line is by combining analytics with reputation feeds, with attack signatures, you can now cover 90%, if not more, 95% of the threats, and you can block a lot of these at the DNS level. So you're offloading some of that work from your perimeter security. And you're also detecting it earlier on in the cycle. This kind of shows you what we can do when you drop in DNS security. Like I mentioned before, you're giving back processing power to your next-gen firewalls, your web gateways, and your IDS, IPS solutions as well. So now what happens is they can do what they're built for, and without having to deal with a lot of the junk traffic and the standard malware traffic, right? So you get more ROI out of those investments as well. And then leveraging DDI data, you can have your threat analysts and your SOC teams prioritize alerts, like I mentioned, and also address a lot of the alerts faster with the DDI data that you get, right? And if your organization leverages a SOAR tool, you can put that data into a SOAR tool, and the SOAR tool can orchestrate the response. Or if your company does not have a SOAR tool, you can also directly integrate our DNS security solution with a next-gen firewall or an endpoint security or an ACK solution, and orchestrate the response with the automatic remediation methods that I talked about earlier using outbound APIs. This kind of shows you all the ecosystem integrations that Infoblox provides. Like you can see here, there are tons and tons of categories of tools that we integrate with. All the top security vendors are integrated into our platform. And the other important thing I want to highlight before I wrap up is the leveraging of a hybrid solution or a hybrid model, right? So you're thinking of doing on-premises DNS security. You may be thinking of doing cloud only. But one of the advantages of doing a hybrid model where you have a cloud-based solution for detecting more advanced threats and for scale, but you also have on-premises DNS security married to that cloud-based solution. Now that gives you, scale from detecting more threats in the cloud, but also more tighter integration with the your on-premises infrastructure, like your on-premises security ecosystem tools. And it gives you better visibility because you're now unlocking the data from your on-premises DDI solution and getting that additional context on compromised devices when you leverage a hybrid model. And of course, you get resiliency and remote survivability. Let's say for whatever reason, your cloud-based solution is offline, you are still protecting your devices using the on-premises DNS security solution. So hybrid model is the way to go when you're thinking about architecting kind of a foolproof solution. So that's it. I mean, it's not rocket science. It's just simple things like putting threat intel on a DNS server can greatly reduce the amount of security tools you need to add to your network. It reduces complexity because it takes a few hours to configure DNS security, and we all know that when you look at some of the other security tools, it takes sometimes weeks or even months to configure some of the other security tools out there. So DNS is super easy to do. Again, it can block 90% or more of the threats, and it can also integrate very nicely with the rest of your security ecosystem and give you better ROI of those investments that you've already made. And the amount of context that you can get from the DDI data is valuable. It's a goldmine of data. It can help with prioritization of alerts. It can help with faster triage, and basically, it's a foundational, cost-effective way to do security and also ease the burden on your security operations teams. So that's it. I mean, if it's one thing you take away from this webinar, it is that DNS can provide that foundational security and help you gain efficiencies, right? So that's it. I think we are ready to answer some questions. So if you have any questions, please do send them through the chat window, and Dave and I will help answer that.
All right, thanks for that great presentation. We have some questions ready for the Q&A. However, if anyone has a question for our presenters, please enter it into the questions window now. Our first one is, can you give me some example use cases of using DDI data for SecOps?
Sure. So I think one of the biggest things about SecOps teams is that to really, day in and day out, they are trying to reduce their incident response times, right, or time to remediation, so to speak. They all know that they cannot prevent every breach that happens, but they come into the picture once a breach has happened. How soon can they remediate? How soon can they precisely pinpoint where the threat is in the network, which device is infected, and how soon can they start the remediation process? So when you look at the DDI data, the DHCP fingerprint information gives information about what type of device it is. The IPAM metadata information gives context about where the device is, the criticality of the asset. Now, if it's a production system that's running critical applications, I think the SecOps teams would want to address that first, right? If it's a laptop, somebody's laptop that went to a bad destination once in, say, last week, that's a low priority threat, right? So again, understanding the criticality of the threat and the criticality of the infected device is something that they can do leveraging the DDI data. So that's a perfect example of how SecOps teams can leverage DDI data to prioritize their response.
All right, thank you. What's the advantage of using threat intel on DNS on top of what NGFWs do?
Right. So next-gen firewalls are great in what they do, right? They protect at the perimeter. They are looking for threats that are going out and blocking it and looking for more. They're doing more deep inspection, right? But one of the things, like I mentioned earlier, is if you leverage threat intel on the DNS layer, there are two things that happen. One is you're detecting the malware campaign earlier on in the cycle, much earlier than a next-gen firewall can detect. And you're also blocking a lot of the bad stuff so that your next-gen firewalls can focus on more deep inspection and more advanced threats. Now, the second thing that that is advantageous is when you leverage threat intel on the DNS box, you are not only blocking, you can block those threats obviously and block those DNS lookups and prevent the malware campaign from propagating, but because the DNS servers are close to the endpoints, they get that request first from the endpoints before it even goes to a next-gen firewall. So the DNS server can exactly pinpoint which device is making that malicious request. Now, if the next-gen firewall gets that request, malicious request, let's say there is no DNS security and the next-gen firewall gets that malicious request, it's going to get that request from a downstream server that has forwarded it to the next-gen firewall. It's not going to get that endpoint visibility. It's not going to know exactly which device made that request. So you kind of lose a little bit of that endpoint visibility if you don't have DNS doing your security.
All right, thanks. How can we deploy Infoblox technology?
So one of the good things about Infoblox technology is that it depends on your architectural needs. So let's say you're looking for, on-premises deployment only. Let's say you want hardware boxes, we can support that. But increasingly, we see our customers leveraging obviously our virtual appliances. So you can, if you want on-premises but virtual, we offer virtual appliances as well. Increasingly, we see customers leveraging our subscription-based licensing model as opposed to perpetual. That's where the industry is headed. And also, if you're looking for a cloud-only solution, let's say you don't want to replace what you have on premises, but you still want the DNS security capabilities, you can always forward your DNS requests to our BloxOne Threat Defense Cloud, which is completely SaaS-based cloud-delivered solution that does all of the malware detection and mitigation and data exfiltration protection in the cloud. It's hosted by Infoblox, and obviously you can you can manage it and control it. You get the reports, and you can log in and check all the activity that's going on and everything that we've blocked. But it's completely cloud delivered and cloud managed. It's a SaaS platform, so you can leverage on premises with hardware, on premises virtual. You can leverage a cloud only, or you can go for the hybrid model that I talked about. So whatever suits your architectural needs and your policies and your company preferences, you can leverage that type of a model with Infoblox.
All right, thanks. I think we have time for one last question. Do you work with SOAR?
Yes, so absolutely. So Infoblox does integrate with SOAR platform. I think the latest one we added is with Phantom Cyber. So like I said, if you are leveraging SOAR, you can send the our DDI data and any security events that Infoblox detects to the SOAR platform, and then that SOAR platform can incorporate it into its playbook and then leverage or do downstream remediation and integrate with the vulnerability scanner or other tools leveraging the integration. Or if you're not using a SOAR platform, we can also directly integrate with the rest of your security ecosystem. So yes, the short answer is we do integrate with Phantom Cyber that's recently bought by Splunk.
All right, well, thank you so much, Krupa and Dave, for your great presentation, and to Infoblox for sponsoring this webcast, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.